This video tutorial is using bump mapping and displacement mapping in VRay. The goal of this tutorial is to show you the difference between bump mapping and displacement mapping, so that you can add more detail to key parts of your scenes and achieve more realistic renderings. Bump mapping is a shading effect that is used to simulate the subtle bumps on the surfaces of geometry. The bump map effect does not deform the geometry. Here we have a simple plane. The goal is to add detail to the geometry with the bump map effect. This will eliminate the need to model the details. In order to add the bump mapping, click on the material and select the material in which you want to add the mapping to. Enable the bump map effect and then click on the M button to add the map. Select the text bitmap for the type of texture map. Next, click on the File Browser button to select the image you want to use for the bump effect. Images used for bump and displacement maps should be grayscale images. In VRay, the black areas mean 0 in terms of the depth, and white means the maximum depth that VRay can reach using bump mapping. The multiplier controls the depth of the mapping. Notice in the rendering that the bump mapping adds some detail to the image. To increase the depth of the bump mapping effect, increase the multiplier to 20. Let's render this scene. Bump mapping is only a shading effect. In some cases, you may not be able to achieve the depth required for the amount of realism you are trying to achieve. To achieve more depth, you must use displacement mapping. Now that we have looked at bump mapping, let's take a look at using displacement mapping. Displacement mapping is a method for adding details to the geometry and is similar to bump mapping. The difference between displacement and bump mapping is that displacement actually deforms the geometry and allows you to obtain more depth. In order to add the displacement mapping, select the material and enable the displacement option. And then click on the M button to add the map. Select Text Bitmap for the type of texture map. Next, click on the File Browser button to select the image you want to use for the displacement effect. Here is a rendering showing displaced geometry. Notice how the geometry is now deformed, and there is more depth and detail in the rendering. The unit system in your scene does not relate to the units for displacement. The unit system for displacement is always in inches. For example, if your scene units are in millimeters, a multiplier value of 1 will increase the depth of displacement by 1 inch, and not 1 millimeter. There are two ways to control the options of displacement mapping. VRay has global displacement settings available in the VRay Options dialog. These settings control all displacement mappings in your scene. There are also settings within the VRay material to control the displacement per material. In this scene, we will control the displacement per material. To enable per material displacement, disable the global option. Once this is disabled, you will control displacement settings in the individual materials. The most important option in the displacement settings is the edge length option. This option controls the quality of displacement. The smaller the edge length value, the higher the quality. The higher the edge length value, the lower the quality. The value of the edge length tells VRay how long in pixels the edges will be for the final deformed geometry. Let's set the edge length value to 2. You can immediately see the higher quality of displacement in the rendering. Look at this example of bump and displacement mapping with a brick material. Let's add a bump map using the same technique as in the first example. Notice how the surface has more details, but it doesn't have geometry deformation. Let's render this scene. Look at the result using displacement mapping and the same texture map used for bump. By adding displacement, notice the deformation of the geometry. The results are more realistic without having to model the details. Here is another example in a common architectural scene. Displacement is used on the stone, wooden siding, and grass materials in this scene. The edge length used in this scene is 12. This will give you lower quality, but will result in faster rendering time. If the edge length is set to 4, you achieve a higher quality, but the rendering time will increase. In this scene, edge length values range between 8 and 12 to provide results with a good compromise between quality and speed. Max subdivision is another important option. This option controls the maximum sub-triangle division of the surface. The default max subdivision value of 256 is the recommended value for most cases. If you require more subdivisions, we recommend that you subdivide the original surface or mesh instead of increasing the max subdivisions. This wall is an example of a surface that has been subdivided. Notice how the surface is divided into smaller areas. Let's render this scene. The rendering time and quality of this image is more than acceptable. During this rendering process, you can see that the rendering buckets calculate quickly and with high quality. The edge length is set to 12. The final image has excellent edge deformation to define the wooden boards, and excellent detail in the surface of the wooden boards. In the image on the right, we are not using displacement. You will notice a straight line at the edges and corners of the wooden boards. This shows that there is no deformation in the geometry. The detail added by using displacement is also visible in the areas where we have grass in our image. Bump mapping is an effective way to simulate some surface depths in your scene. However, displacement can allow you to add more detail when you are trying to achieve more realistic renderings.